this video, we will discuss getting user input, specifically how getting input provides flexibility, what's the difference between hard and soft coding, how to use sys.argv, what's an index error, how to use quotation marks for user input, the argpy get parameter as text method, what sys.argv holds, and handling file paths with the OS module. Writing code so that it takes arguments makes the code more flexible. Recall the in-class exercise, buffer clip.py, where we hard-coded the park file name, the buffer distance, and so forth. We could make that code more flexible by removing the string literals and replacing those with, on the right here, to substitute for the code that has these string literals for each of the parameters. And then that way, when we run the script, we could run it on a different input data set, such as if we had a shapefile on Yosemite and we could look at the fire damage extent in that area. And then it would buffer and clip whatever we passed in to the script. Hard coding means assigning a value in a program so that it can't be changed without altering the code. On our previous slide, we said that fire damage was hard coded because we're using a string literal to set it, as opposed to soft coding, which is obtaining a value from an external source such as user input. We could be getting the fire damage with sys.argv1, and that would allow us to set a different file each time we ran the script. We'll also learn how to read files that could be used to soft code the values in a script. Recall add.py. In that script we use sys.argv to get the two numerical values to sum together. Sys is a built-in system module. Sys.argv is a Python list. Now that we've gone over Python lists, that may make a little bit more sense. It's a sys property that's a Python list. The IDE, when you run it, automatically populates the list. When you run with Python Win, you use that arguments box, and that sets the value of the argument vector. Before the dot, and in this object dot property, is the system module. After the dot is the argument vector Python list. So what we're doing with the square braces and the 1 is we're indexing into position 1 in the argument vector. We're accessing the list using indexing. If we print the entire vector instead of just an index in the vector, we see the square braces around the list with the comma separated values. In this case, we've passed one argument into the script, and it's given us a length of 2 for the vector. So there are 2 items in this list. Can you guess what the first item is? The first item in sys.argv is the full path file name of the script. In this case, our script is named buffer_clip.py, and this was run with the script in c/my_documents. What is the minimum value for the length of the sys.argv list? It must have at least one item in it all the time. Even if you don't pass an argument, the minimum value is going to be 1 because that first position will be populated with the script's path. If your script is written so that it requires arguments and you run the script without any arguments, one of the built-in exceptions will be thrown. You'll get this traceback message with an index error being reported. So what will happen is it'll get to the first argument that's being requested and try to index into that Python list into position 1, which is the 0 base, so it's the second position. And if you haven't passed any arguments in, that's going to be indexing beyond the end of the list. So list index out of range occurs when you try to point to a position in a list that hasn't been populated. Again, if we print the list, we get the path of the script. If we print the 0 index position, we get the path of the script. If we print the list, we get the square braces. If we index into it, we just get that string. Sometimes file paths or other input data can have spaces. You need to have spaces in the information. Say, for example, we have a directory right under the C drive called African elephant, and under that has raster data that we want to operate on. If we pass in C/African space elephant rasters, the script is going to take this as 2 arguments instead of 1, which is what we intended, because the arguments, you can tell where one stops and another begins based on spaces. They are space delimited. We have a script down here that prints the arguments. So it's printing the first argument and the second argument that it sees. And if we run the arg spacing this way with this input parameter, we get the first argument is C African and the second argument is elephant/rasters because of that space. So in order to prevent that problem, we need to use quotation marks around an argument that has embedded spaces. That way we'll get the whole first argument, C/African space elephant/raster, it just wrapped here because it's on a slide, but this is taking the whole path as a first argument, and then it doesn't see any second argument. Word of warning is that you do have to use the double quotes in this situation. The single quotes will not be interpreted by IDEs as the double quotes are. The double quotes are taken to be a grouping indicator, and they don't appear when you print out the values that you're getting in. So they use them for grouping and then peel them off. Whereas with the single quotation marks, the single quotation mark is read literally. So then in this case, the argument is still split into 2 arguments, and the quotation marks appear. You may have noticed that I used the get parameter as text method on the previous slide. This is just an alternate to the sys.argv provided by ArcPy. One thing, the reason that it was used on the previous slide is that if you try to access a parameter that is not listed, you don't get an index error like with sys.argv, which is simply looking into a list. So with get parameter as text, you have to pass in an index, which is 0 based in this case. If we say 0, we don't get the script path using this. It just gives you the first user argument, and this will get the second user argument, third. Usually we'll default to sys.argv because ArcPy can't be used in scripts that don't import ArcPy, and importing ArcPy takes extra time, so it shouldn't be imported when you're not using it for something else. Here's the same script that we saw on the previous slide, but using sys.argv for each of those 3 arguments. Notice the previous slide had get parameters text 0 as the first one. This one takes the 1 because of the script path. This is a good approach because it can be used for standalone scripts that don't require ArgPy. Handling file paths with OS is a really useful skill to have, because if you're going to be getting arguments from the user that have data paths, then you may need to be able to manipulate them. Say, for example, to find out what directory the file is in. So if you've been given the full file path, you want to maybe peel the directory off of that one so that you can get the path for other data that's in the same directory. OS is one of those built-in modules, just like sys is a built-in module. OS has a submodule called path, so notice we're using the double dot notation here. We can get the directory name from a file path by using os.path.dir name. So let's see what the dir gives us. So that's peeled off D data. We can also get the base name, that's the other part of the path, which is the file name, the last part of the path without the first part. So the name is delwatergap.shp. There's an os.path.exist method, which will return true if the path that you've specified in parentheses exists. So if we say the dir plus the name, we get C data delwatergap. And take a moment to predict, is this going to return true or false? If you guessed false, you're right. Do you know why? The reason is that when you concatenate the dir and the name, you're concatenating exactly what those variables contain, and there is no backslash behind data or before delwatergap. Therefore, the data path is no longer what we actually have on our machine. There needs to be a slash between data and delwatergap. Otherwise, it's looking for a file named data delwatergap. This is actually a pretty common need to take a file path and add a file name to the end so that you can say create an output path for something, or specify the location of some data that's in a known directory. And you don't always know if the file path has a slash at the end or not. Say if it's coming as input from a user. Therefore, there's a function called join, which is the os.path method, that will take a series of path and file name elements. It can be more than 2, but here we'll just use it on 2, and it will join them together in a way that creates a file path. So if there isn't a slash between the 2 elements, it will add one in there. And here it's given the escape sequence / so that the backslash can be recognized. This is, of course, equivalent to a single /. In summary, we used dir name, base name, exists, and join, and those are all os.path functions. You may remember seeing exists before when we did argpy.exists on one of the previous lessons, which also returns true or false depending on if the file exists. There are numerous other os.path methods. Here are a couple more examples using an os.path method to take a path and split the extension off of it. You can use the os.path.splitExt. Why might you want to do this? The most common reason that we've seen is that you want to take the file name, say parks.shp, and add something to it. So use the original file name that's, say, coming in from a user or outside input, and you want to use that as the output name by appending out to it. If you simply add out to the end of this, you'll get parks.shp plus, you'll get out at the end of it, parks.shp out. But what you really would want is to say parksout.shp. Then you need to split these two so that you can get that first part and concatenate with it, and then concatenate the second part back on. So this splits the extension off of the file, and you get parts like this. This is a tuple, these parentheses around it. And of course you can index into a tuple to get the first one. We can do these, combine these two lines together into one line and say os.path.splitExt my shapefile 0, and that will return the first part of the file name without the extension on the end. You'll see this in some of the example scripts. As I mentioned, there are numerous os.path methods, just a few of those. For example, getSize returns the size of the file that you pass in based on the file size in the directory. If you look at it there, that's a really useful one. getMtime, that's get modification time. Isdir tells you whether or not the path that you're passing in is a directory, or isFile, similarly for a file. Later on we'll discuss the walk method. There's a link to the reference library for those, the help section. Now we'll do an in-class exercise to practice using some of the things that you've just learned. But before you start, I want to talk about os.listdir, which is one other OS method. Notice it's not os.path.listdir, it's just an OS method directly under that module. It lists the files in the directory that you have specified in the parentheses. In this case, there are 9 files in ctemp, and here is the list of them. So the instructions for this in-class exercise are to use sys.argv to get the full script path, path.dir_name to get the directory where the script resides, and then use os.listdir to get a list of the files in the directory. This would be a way to get a list of the files wherever your script resides. If you move your script around, it would still give you a list of files that are in that directory with it. Pause your video recording and make an attempt at solving this problem. It should just be a few lines of code. Okay, now we'll discuss the solution. First, you need to import both OS and sys because you're going to use both of these modules in this code. To get the full path for the script, we use sys.argv0. As we said, that contains the full path for the script. Then we can peel off the directory part, the place where the script is located, by using os.path.dir_name. If we save that in D, we can say os.listdir of D, print those out, and that will print a list of the items in the current directory. Summing up, Topics discussed. User input for flexibility. When you have hard-coded, the code needs to be changed in order to have the code do anything different. Go to soft-coded, then you can expect user input, and it can do geoprocessing on different files depending on what's passed in. In a later lesson, we will discuss graphical user interfaces so that the code will be truly shareable with others who are not familiar with code but can use the graphical user interface to provide input. Meanwhile, the script on the back end can still handle arguments in the same way that the code that we discussed today does. Sys stands for sys module, and that has a property argv, which is the argument vector, a Python list. If the user fails to pass in enough arguments, an index error will occur because the code is trying to index into a piece of a list that does not exist. Quotation marks need to be used if there are embedded spaces. Get parameter as text exists as an argpy method that can be used as an alternative to sys.argv, but we don't use that very much in the class. The 0th index of sys.argv contains the script's path, and we discussed an example for how to use that path to make a script that prints the contents of a directory wherever the script is put. We had os.path methods for handling paths that are passed in by users, and we also looked at os.listdir method. The next lesson will discuss pseudocode.